Hello students, welcome back. Previously we did some right angle trigonometry. Now are you ready to go over to arbitrary triangles? We're going to approach on two different viewpoints. One in the viewpoint of sine, and then in section 3 we'll use cosines. Sines first, the law of sines, and that's the topic for section 2. Here we go. Given triangle ABC, the lengths of the sides are proportional to the sines of the corresponding opposite angles, so that sine of capital A over small a, sine of capital B over small b, and sine of capital C over small c, they're all the same. Or we can take reciprocals them all and then write like this, depending upon which one is more convenient for you. Now, typical convention here is A, B, C. Those capital A, capital B, capital C, those are angles. And then the opposite side, small a, small b, small c, those are lengths. And then I color-coded them as well here. Why is this true? Interesting question, but I'm going to postpone that. I'll prove it, but I'll prove it as an optional video. It's not for everybody. Instead, let's focus upon how to utilize it. First problem, solving a triangle, and this is very typical example. We know two angles, so third angle is easy to find. Internal angles of a triangle must add up to 180 degrees, so 20, 25, they add up to 45 degrees. So the third angle must be what? 180 minus 45, yeah, it's 135 degrees. So you see, you don't even need calculator. You need only mental math to figure out the third angle. And as for the other sides, small a and small b, well, that's going to be a bit of a problem. So here we go. It's kind of like this. A is 20 degrees. B is, well, unknown at the moment. C is 25 degrees. A is unknown. B is unknown. C is about 80.4. Well, nothing is accurate, so it's going to be more accurate to use, it's going to be better, more preferable to use this approximate equality sign like this. But hey, typographically it's easier, so let's use equality sign, and I'll make some adjustment at the very end, okay? Please forgive me. It's difficult to typeset this way all the way. Okay, that's a structure, and this is easy to find. What is B? Capital B is 180 minus 25 degree, 20 degrees, plus 25 degree. So that's 135 degrees, right? So this is 135. All right, that was easy. Now finding out small a and small b, well, that'll require law of sines. I can use this form or that form. Which one am I going to use? Either way, I can use it, but the latter one will be a little bit more convenient. The reason, I'm looking for small a and small b, and in the latter expression, those are in the numerator. So I don't have to flip them over. So, all right, let's copy and paste this thing here. And then a lot of fractions. So let me increase the font. And then, okay, all right, let's work it out. All right, what is capital A? What's capital A? My capital A is 20 degrees. What's capital B? We just found out to be 135 degrees. And what's capital C? 25 degrees. Now, do you know A? No. Do you know B? No. Do you know C? Yes, I do. 80.4. Okay, from here, we can find A and B. How? I can decompose this into two equations like this. Take bigger font again, and then skip this. A equals to that, and then let's do it again. This time skip that, and then alright, small b I can find out from here. So all I have to do is to flip this to the other side and flip this to the other side, right? On the second thought, let's do it this way. So okay, here, flip this one to the other side. So come on, come on, come on. Okay, all right. Copy and paste, and then flip this to the other side. And then punch this into calculator. You're gonna get something. Let's do the same thing here. All right, and then flip this denominator to the other side, and then punch this into calculator, and I'm gonna get the answer. All right, that's how you work out a triangle, solve a triangle, if you know two angles and a side. Two angles, so you can find out the third angle easily. Yeah, they add up to 180 degrees actually. And then we use law of sines. Put in all those numbers, and from here we can decompose that into two equations. One for A and one for B, and we can solve those easily, one by one. In the end, punch in the calculator, you're going to get the answer. And if I do, I'm going to get these numbers. Yeah, the angle capital B, that was easy. And, you know, those computation, 65.1, 134.5, respectively. Just calculator work. Here, in my answer key, I use this wiggly equality signs for approximation. Yeah, that's a little bit more accurate expression. So, okay, I don't need these solutions anymore. Now let's go to the next problem. This time we have an angle and two sides. It's dangerous here. If you have two sides and an angle in between, then that'll determine a triangle uniquely, SAS. But in this case, we have angle A and the opposite side and the other one. So this may or may not work. Who knows? I have a reason to believe it'll work this time. Otherwise, I would not have written it in part B here. I would have buried it in part D or something. Okay, all right. Let's see. Basically, it's this kind of situation. A is 45 degrees. And then B, well, I don't know that. And C, I don't know that either. And A is 7 square root of 2. And then B is 7. And then C, I don't know that. Okay, all right, that's the structure. Okay, all right, let's use the law of sines. This time we have to figure out the angles. So I think the first convention is going to be a little bit more convenient. Okay, all right. What do I already know? 45 degrees. And then 7 square root of 2. And B is 7. And okay, that's it. I don't know any other. Okay, how do we proceed? Well, let's take one step at a time. Forgetting about this, with the remaining, I can find out the angle B. Once we have two angles, capital A and capital B, I can find out capital C. And then let's go to small c. In any case, yeah, that's what we have to do. Let's find out capital B from here. Alright, let me rewrite this. Bigger font. And then let's not worry about this part. And let's find out capital B. Before that, looks like I can do some simplification. Never mind. Sine of capital B is, flip this one over to the other side. I'm going to get 1 over square root of 2 and sine of 45 degrees. So 7 and 7 cancelled out. Wait a minute, sine of 45 degrees. What is sine of 45 degrees? One over square root of 2, that's sine of 45 degrees over square root of 2. So the entire thing is 1/2. Or do you prefer to use square root of 2 over 2? So square root of 2 over 2. Either way, after cancellation, I'm going to get 1/2. So sine of B is 1/2. Does it tell us anything about B? So inverse sine of 1/2, that's going to be pi over 6. We are using degrees here. So 60 degrees. Or B is 150 degrees. You know, people tend to forget the latter one here. So the answer may not be unique. It'll turn out, however, this is valid, but this is not. In the end, therefore, it'll all work out. Here's what I'm talking about. Sine of capital B is 1/2, so it will be 30 degrees of 150 degrees. If 30 degrees, then we can find out a third angle like this, and 105 degrees, it'll work out. If 150 degrees, then it's not going to work out because 45 plus 150 will exceed 180, so that's invalid. So the latter case is impossible. So we have only one possibility, 30 degrees. So we have a unique solution. We are just lucky. So capital B is 30 degrees. And then capital C is 105 degrees. Now let's find out small c. A is 7 square root of 2. And capital A is 45 degrees. Capital C is 105 degrees. From there you can solve for small c. And it'll turn out 13.5 something according to this computation. So we found out everything. All three angles, capital A, capital B, capital C, and all three sides. Small a originally, small b originally, and now small c as well. Okay, we'll do the other problems in the next video. That'll do it.